Lepidico is an ASX-listed lithium chemical development company. We've got a market cap of around $100 million. Our strategic objective is to develop a vertically integrated lithium business from mine through concentration to lithium chemical production using our proprietary technology. We've got a process called LMAX, which produces lithium carbonate from lithium mica and lithium phosphate minerals, and we also recently announced a new process called LOMAX that can produce lithium hydroxide. We've got a pilot plant that's under construction currently in Perth, in Australia, and we've also got what we call our phase 1 plant project in the closing stages of feasibility study. That project is for a chemical plant in Sudbury in Canada, and the feed for that will be coming from Portugal. We're well capitalized. At the end of December, we had around $8 million in cash, and we're funded for all of these programs. Here you can see a schematic of our vertically integrated business model. On the top left, you can see the mine. In this instance, for the phase 1 plant project, that's the Alvardes mine in Portugal. The ore from there will go to a concentrator, which will be newly built, purpose-built for this operation. It's a relatively small concentrator that would be looking to produce around 50 to 60,000 tons of lithium mica and lithium phosphate concentrate per year. There is also potential in that jurisdiction to be producing a feldspar concentrate as well as a byproduct. The concentrate then gets shipped to the chemical plant for the phase 1 plant that is located in Sudbury in Canada. You can see there that the main reagents going into that are ubiquitous in mineral processing, sulfuric acid, lime, and limestone. We don't use a lot of energy. That process is undertaken at atmospheric pressure and modest temperature. Importantly, we produce a suite of byproducts along with the main lithium chemical product. The first of those is an amorphous silica that can be used as a building material, and then SOP fertilizer. There is also potential for other byproducts. This gives you a sense for our footprint. As I mentioned, we're ASX listed. Our registered office is located in Perth in Western Australia. That's where we have our technical capability as well. We do have some exploration activities going on in Australia, but the key feed source for our phase 1 project is the Alvardes mine in northern Portugal, and I'll get to a bit more detail on that in a second. The concentrate from there will be shipped then across the Atlantic to Sudbury in Canada. The reason for locating the chemical plant in Sudbury is that our process is sulfuric acid intensive, and as some of you may be aware, and Sudbury is a major nickel mining area, and they've got 2 large nickel smelters there that produce nearly 1 million tons of sulfuric acid a year. So focusing in on the feed source, this is an aerial photograph here of the Alvardes Lepidolite mine in northern Portugal. You can see the 2 existing pits there. The strike extent is around 1 kilometre. Until we came along, no drilling had been undertaken here at all. So the mining started back in 1992. We drilled out a modest resource in 2017. In the 4th quarter of last year, we did a second drill program for our feasibility study. We announced the assay results from that a couple of weeks ago, and we've identified several further lithium mica and lithium phosphate mineral-rich pegmatite sills, and we do expect to be materially expanding that resource. The new resource estimate should be available in the next 2 to 3 weeks. So the plan here is to expand this mine, particularly pushing that southern pit up to join and merge with the northern pit, and then build a concentrator here. That concentrator will have a capacity of around 150,000 tons a year of ore feed to produce around 50 to 60,000 tons a year of concentrate. moving on to the chemical plant, our proprietary process is called LMAX. It is subject to a provisional patent application in Australia, and we're now in the national phases of that, and we'll be expecting to get patent protection coming through in first jurisdictions later on this year. You can see there on the top right-hand side the minerals that we're interested in. They're largely lepidolite, zinwaldite, and amblygonite. We do see amblygonite at Alvardes. It's a particularly nice mineral in that it contains about 10% lithium oxide. The process, LMAX, uses sulfuric acid and limestone, so common use reagents in mineral processing. The equipment is relatively straightforward as well. The start of the process is leaching with leach reactors, so it's a saturation sulfuric acid leach. We then go through a series of impurity removal steps using lime and limestone to adjust the pH. The equipment in there is largely filters for solid liquid separation steps and crystallization. The byproducts are important to the economics of the project, and to strategically locate an LMAX plant, we need to be close to affordable, abundant sources of sulfuric acid as well as markets for these byproducts. And the other important point to note here is this phase 1 plant is designed to produce around 5,000 tons a year of lithium carbonate. That scale is based on being large enough to be able to make a reasonable economic return, but small enough for it to be able to demonstrate commercial viability of the process. If scaled up to 25,000 ton range, which seems to be the run rate for a lot of lithium chemical plants around the world, I would envisage some very attractive economies of scale at that size. Back in February, we announced a new process, which we've called LOMAX, the OH being for hydroxide. This came about last year when we were doing a risk review for our feasibility study for our phase 1 plant project. And we identified production of byproduct sodium sulfate as a potential risk to the project. If we didn't have a market for sodium sulfate, it wasn't clear how we could potentially dispose of that. And some of you may be aware that sodium sulfate is a common byproduct for a lot of spodumene processes and or downstream spodumene processes. So we looked for an alternative process step that could produce either lithium carbonate or lithium hydroxide without byproduct sodium sulfate, and LOMAX is the result of that. When we came to factor this into our phase 1 plant project, we realized that there was a capital cost saving in the back end of the plant and an improvement in operating costs. So we see LOMAX as being a process that is not just applicable to what we're doing processing lithium mica and lithium phosphate minerals. It is applicable also in any sulfur-based chemistry used for processing of lithium chemicals. In other words, it is applicable to downstream conversion of spodumene concentrates. What you can see here on the right-hand side is the LMAX process flow sheet. LOMAX just fits in at the back end of that, so we produce this intermediate lithium sulfate product. And LMAX is designed to produce lithium carbonate. What we're now looking at doing in our feasibility for the phase 1 plant is substituting that back-end process step for LOMAX to produce lithium hydroxide. There is a provisional patent application for the process, and so if anyone's interested in this process, then we'd need to be entering into an NDA. Quickly on the pilot plant, this is using all industrial equipment. It's a step up from our previous mini plants that we've run at the laboratory scale. Its throughput is around 15 kilograms per hour. We announced yesterday that the project's within budget and on schedule, and will be commissioning next month. This is a schematic of the phase 1 plant. This is about 500 times bigger than the pilot plant. We're now engineering Lomax into the back end of this plant. And this is the plant that we'll be looking to build in Sudbury in Canada. Finally, the residue from LMAX is largely a gypsum and some alunites, and we've done some work through the University of Waterloo in Ontario to be using that as a product as well for environmental remediation purposes. That being the case, we'll have a chemical plant with no waste, no residue, and the only emission is steam. So a very sustainable project. So in summary, we're looking to fast-track the business through to free cash generation, and in so doing, demonstrate the commercial viability of our processes. Thank you.